Hello and welcome. I'm Christine Perret, and this is the February 18th webinar for about augmented reality in the aerospace industry. We'll be recording this webinar, so there'll be ability to review it later if you like. And very pleased to have with me today area members and guests, and look forward to sharing a lot of information, interesting new developments with you. So let's go ahead and get started. This webinar is the fifth in a series that the area is producing. We started by introducing ourselves and some general concepts, and now we're diving into a specific industry today. Before I do that, I'm going to give you a little bit of background and information about our industry organization. Like to explain to you why we think that augmented reality is so critical to the future of workplace performance. Well, we like to think that augmented reality starts by building up upon an enterprise IT system, and by giving a user access to the richness of the information system, especially when they're working in the physical world, they can access the most relevant data and that which is fresh and relevant to them at that particular point in time. They can use resources, both human resources as well as other resources that are at their disposal, more quickly and easily. And augmented reality very frequently can be used to inspect or to certify that there's been some task done correctly or according to plan. Augmented reality can also, as a result of the things that I've shown you on the left-hand side of my screen, it can reduce the time necessary to perform tasks, or also reduce the number of errors. And if you can reduce the time and the incidence of errors, you're probably going to be able to reduce the costs or increase productivity. So all of these factors together can boost the operational efficiency of a company. Our vision is that it is necessary for the smooth introduction of this technology for there to be a global member-based organization focusing specifically on the enterprise adoptions. We start with the customer, so large entities, large customer entities, enterprises that have a lot of assets as well as a lot of people worldwide. We combine that with providers of components and technologies and of services, those who can provide solutions to meet the customer needs. And we have a third segment of our ecosystem that we recognize as being highly influential and valuable, and those are the non-commercial entities. Entities such as trade schools, universities, research centers, industry associations, standards associations, and together these three segments, the customers, providers, and non-commercial entities, bring about a new technology ecosystem that hasn't existed before. So our mission is to help those companies that are providing technologies as well as those that can deploy it to achieve greater operational efficiencies. Now, we don't think we can get to widespread adoption without first having a smooth introduction experience. And we believe that to integrate augmented reality into the rich enterprise systems, there needs to be interoperability and observance of open APIs and standards where available. We are now quite a large organization. We have all of these members. Some of them you recognize, they're household names. Others less well known but important to our ecosystem. So today what we're going to be focusing on is a specific segment of a specific industry, that is the aerospace industry. We have several members who are already very, very well established in aerospace, and so for this reason, it's our pleasure to welcome them. I'll be going over I'll be introducing them individually. Today we have with us Paul Davies from Boeing. We have David Doral from Aerotech Solutions. I'm sorry. Jim Novak from Talent Swarm, and Raul Alarcon from the European Space Agency. It's now my pleasure to turn it over to Paul Davies of Boeing to tell us a little bit more about augmented reality in his company. Paul, would you like to get started?
Yes, good morning. Thank you, Christine. Thanks for the introduction. Again, my name is Paul Davies. I am an associate technical fellow with the Boeing company. Been with Boeing around 13 years, and I work in the research and technology division of the company, where we look at really advanced technologies across the spectrum. My focus is manufacturing technologies, and we apply those, or we research, develop, and then apply these technologies to our business units, both the commercial and the defense side. So I thought I'd give a little brief introduction to the company. The three major product lines we have and what we do today: we design, assemble, and support the 7 series commercial jetliners, and that's probably what we're most well known for. The 737, 747, all the way up to the latest model, which is the 787, the Dreamliner, which is our latest aircraft, just the most complicated commercial aircraft we've ever built in terms of the technology that goes into it, and also the manufacturing process that are required to assemble it. And then secondly, perhaps what we are somewhat little bit less well known for is designing, assembling, and supporting defense systems. Our defense business is based out of mostly in St. Louis, and that's where we build F-15s, F-18s. We have things like the V-22 rotorcraft program in Philadelphia, A-10, and other defense programs. And then perhaps again, the third point, and maybe even what we're even less well known for, is designing and assembling satellites and launch vehicles. Our satellite factory is based close to where I am in Southern California. It's right by the Los Angeles airport in El Segundo. And we, over the years, have designed and launched many different models, including the GPS-2 constellation, Intelsat, Inmarsat, and many others. And I wanted to kind of highlight really the scale of what we're doing. In the second part of this slide here, these numbers are actually a little bit out of date, so they're probably higher, but in the next 24 hours, over 3 million people will board, over 42,000 flights built by Boeing. 6,000 of our military aircraft will be on guard with the defense forces of over 23 countries around the world. Wherever you are in the world, over 340 of our satellites will pass over your head in the next 24 hours. And it's really this last one that I'm most concerned with, and I will be focusing on today, and that is more than 2 new airplanes will be produced and will roll out of the factory doors in the next 24 hours. That's 2 airplanes every single day, more than 2 actually, every single day are built and leave the factory. And it's the scale of what we do for that last one, the complex procedures we have to do, the number of touch labor task instructions is really where I spend most of my time, and there's a huge pressure to improve the quality of what we do, increase the rate so we can meet our customers' demands, and that's really where I'm going to focus today. If we can go to the next slide. So as some folks may know, Boeing actually has quite a rich history in augmented reality, going back actually to the late 80s. This is a picture what 2 of our researchers, Dave Mizell and Tom Caldell, first kind of conceived the concept of taking of merging the digital world really with the real world and to provide useful information. And this image here is a very primitive, very early attempt or example of augmented reality, and this was up in Everett, and it's in a commercial wire shop. And you can see the person is wearing an early head-mounted display, and on that display there is some very simple guidance about how to route those wiring bundles that he's laying up on the board there. And the graphics were very primitive. Like I said, it was just really simple 2D lines. The tracking system is using that network of dots on the board there. There were, of course, many issues, ergonomic issues, tracking issues. But, the reason I highlight this is because, it was, approaching 30 years ago, we were already thinking about how do we merge the vast amount of digital data we have with the real world in a way that will help mechanics. And since then, we've had peaks and troughs in terms of the rate of acceleration of development of augmented reality. I think over the last 5 or 6 years, partly due to kind of a renewed focus on augmented reality and partly due to the available technology, we're seeing kind of a boost in where we are today. And I'll be able to maybe elaborate on that a little bit later. So if we can go to the next slide. So some of the things we're doing at Boeing using AR, today we have 5 pilots that are out on the shop floor around the company, actually across the enterprise, different programs. And we're using the technology to do a number of different things. So, of course, prime interest to us is technical communication. And that goes back to the complexity of the tasks that it takes to build aerospace products. Like I mentioned, the complex 787. We want to be able to communicate intricate procedures, building delicate assemblies, and have them built right the first time, and in the minimum amount of time. We want to increase the rate. So using AR to provide technical communication is a very powerful mechanism. We're also wanting to use augmented reality to train or to help in training for touch labor tasks. It's been shown that when people learn using augmented reality, when they experience their steps in an augmented fashion, in order to learn a task, they are much more likely to remember the steps correctly, and they're going to learn it much faster. So we have one of our pilots is focusing on training new mechanics using augmented reality to do a task. And the third one is inspection. We use the term virtual X-ray. Of course, there is no real X-ray, but we can see things behind the skin, for instance, of an aircraft, maybe wiring bundles or structure that is behind the skin. And we can do that because we have the 3D definition of what's behind that skin. So it's just a matter of rendering it over the skin, and it kind of gives you like an X-ray effect. So that helps in assembly and inspection. And then lastly, we're interested in validating assemblies. When a job is completed, we want a mechanic to be able to compare what he's done to the design digitally, and then very quickly understand if there are parts out of place or parts missing and things like that. So that will help us improve quality. So these are the kind of the main 4 thrusts or the touch points that we're really focused on in applying augmented reality. If we can go to the next slide. And so this is really some data of why we're so interested and why we're focused on augmented reality. We did a study with a university in end of 2014, and we compared different modes of delivering technical instruction to a person to do a touch labor task. And the numbers we saw were really quite impressive. When we compared augmented reality to other techniques, such as using a PDF or a 2D document, we saw the time to assemble an article went down by over 30%. And at the same time, even though they were building it faster, the quality, the first-time quality, was improved by 90% in terms of the number of mistakes that were made. So when we look at these numbers, and we will probably never realize numbers this huge across everything we do, but even if we only see a fraction of these numbers, and you look at the scale of what we're doing, rolling 2 new airplanes every day out of the door, the potential is huge. And so this is really why we're so focused on augmented reality. So I hope that provides a quick introduction, and I think we're going to have some time to maybe discuss some of these topics later in the webinar.
That was great, Paul. Thank you very much. And now I'd like to invite David Doral from Aeronautics Solutions.
Thank you, Christine. Yes, as Christine has said, my name is David Doral. I'm the Director of Industry and Manufacturing Engineering in Aeronautics Solutions. We are basically an engineering company specialized particularly in manufacturing engineering services. we do other things, as you can see in this slide. On the left, you can see our activities around the airport life cycle, providing engineering services to design and provide any type of consulting for airports. The right side, you see also our defense activities. We develop UAVs and other critical systems, weapon systems. But what is more relevant for our chat today is the center part of this slide, where we cover what we call the aircraft industrial cycle, or basically, as I said, a manufacturing engineering services provider for companies like OEMs. OEMs, aircraft OEMs, like it could be Boeing or it could be Airbus, typically our main customer, but also for aerostructures first years. And as part of our services, what we're trying to do is to, we've tried to develop our own strategy in what lately is called Industry 4.0. And where we think augmented reality is going to play a significant role. We're trying to identify, develop, and integrate new technologies that could be useful for our customers, and also give us a competitive edge compared to other providers. And that's why we're investing heavily on R&D around augmented reality. So we can see in the next slide, where we're picking up in this case, and actually that refers to one of the comments that Paul made before, that Boeing was the pioneer of augmented reality in the aerospace industry, and basically the introduction of augmented reality in the industrial world. There were some prototypes at the time, more than 20 years ago. Those prototypes didn't quite deliver what was expected. I guess that the technology was not there at the time. But in the last 10 years, we've seen how for that particular problem, the assembly of electrical harnesses for aircrafts, other solutions inspired maybe on that augmented reality approach, but following a slightly different route, and based on the tactile screens, touch screens, have been developed and commercialized in the last 10 years. And those two photographs are an example of that. But picking on that, we have seen lately, and AirTech has actually played a significant role there in the development of a solution for that problem. I mean, the assembly of electrical harnesses based or using augmented reality solutions. In this case, the approach is probably slightly different, similar but different in terms of the solutions that we're talking about are projection-based, projecting over a flat board where the electrical harness is going to be assembled. All the information, the routing, the technical specifications, the step-by-step tasks that must be followed in order to put together all the different elements, connectors, wires. So those are solutions that are right now out there, and we can say that because we've been partnering with Airbus to develop one of those solutions. Unfortunately, I can't show anything there because it's proprietary information of Airbus, although we are discussing and we're negotiating the commercialization of that technology because we are the integrator of that solution for Airbus. But we can say that right now they're operational, and there are solutions that OEMs like Airbus are using right now, and that are allowing to achieve the goals that Paul was mentioning before in terms of a reduction of production time, reduction of errors, and increase of productivity. In the next slide, we can see also other examples where augmented reality is being used, or at least tested, in the aerospace industry, particularly for work instructions, step-by-step work instructions. This is a project that we've been involved somehow also, driven by Airbus, to try to test, to check whether augmented reality again can deliver some of the benefits that were claimed through, or that had been proven, through studies like the one that Paul mentioned before. And again, we're taking part in the introduction of these technologies. We're participating as part of our services in the introduction of those technologies in the assembly of different components, structural components in Airbus aircraft as part of our services. Also, another example where we think that augmented reality is going to play a significant role is in enhancing the functionalities of what we call remote support. And we know that because we're developing our own remote support platform, and here we're trying to show to explain how that is going to provide some value to OEMs and where augmented reality is going to add some value. Typical problem we encounter that we face as the services that we provide to our clients is whenever a worker, whenever an operator is putting together, is assembly, integrating a component in a part of the aircraft, structural component or some system or any other element, and whenever a situation happens where what the worker sees doesn't match the drawings or the models or the actual status of or the theoretical status of the assembly of that aircraft in that point in time. So imagine that there's a missing element, or there's a hole where there shouldn't be a hole, a connector is missing, or there are more holes than there should be, or there's something that apparently is damaged. Usually what happens is that that operator raises a hand, so to speak, and calls an engineer that is meant to provide or is meant to resolve that issue. Those engineers are typically with Airbus, our people, our engineers that we have on the final assembly lines of Airbus providing that service. What we're trying to do is to introduce a tool that could help us reduce the number of those engineers, or more than that, try to identify the right engineer that could provide a very quick answer to that question. So if we go to the next slide, we'll show how we're trying to implement that through our remote support solution. This is actually an image of our prototype of that is a tablet-based prototype. Where we're trying to do is to establish a direct communication in direct contact with our team of specialists that could be basically located anywhere in the world. Usually they're based in or they're meant to be based on our central offices. So the first thing that that remote support tool will do is establish that contact, and through the initial information that the operator, the worker, will provide in terms of what is the nature of the issue, the nature of the incidents, the system will be able to identify automatically who is the best specialist of our team to provide a quick answer. So in the next slide, we'll see that that connection is established, the right person is chosen, is selected, and that communication takes place. Communication in both ways, both directions, will allow to first explain what is the problem, and through the introduction of augmented reality, and that's something that we can see in the next slide, we can see that through smart glasses, and that is a part of future functionality that we'll be adding to our tool. For instance, with the smart glasses, would be able to first allow the remote specialist see what the operator is seeing, and at the same time project over those smart glasses, but it could be also a projection-based system. But in this case, through smart glasses, show particular indications to tell the operator the step-by-step actions that he should take in order to resolve that potential issue, whether it's resolvable or not. In some cases, it will be a question of escalating that issue. And the good thing is that this technology will allow that in a very in a seamless way, and will integrate with ERP systems or with any other enterprise master system that the company may have in order to record and forward that consultation or that issue to, for instance, the design team that could be in charge of resolving something that cannot be fixed on the spot. So if we go to the next slide, please. This is just a summary of where we think augmented reality can contribute to the aerospace industry and in particular to manufacturing through improving productivity and quality. And again, going back to the study that Paul was mentioning before, it's going to accelerate training for sure, because it's going to make it much more intuitive. It's going to spread knowledge, and a way to do that, for instance, and going back to the remote support application that we've mentioned before, it will be very easy in that communication, two-party communication, to introduce in the middle a junior engineer, for instance, and actually it could be part of the solution that not only we have a worker on one end and then a specialist, engineering specialist at the other end, we could have also a junior engineer close to that workstation that tries to identify or tries to help in the solution of that problem, and that person could be actually the one that establishes the communication with the remote expert team, so that he or she becomes part of the solution, and at least is part of the step-by-step solution that the specialist could be providing at the other end. So again, as a way to spread knowledge. Another thing that I think augmented reality, another benefit that augmented reality is going to bring to the industry is going to be the integration of the human component in the industrial Internet of Things. And what I mean with this is, at the moment that we see workers using work instructions based on augmented reality, the devices of this type would allow very easily to record, to document whenever a task is fulfilled, is completed, so that is registered, is recorded in the ERP or in the master planning software or platform that the company may have, in a way that it will be almost without any effort, and that way we'll be able to integrate the human component and the human factor in a world of machines that are meant to be connected as the industrial Internet of Things is meant to promise. Of course, it enables true remote expert advice, as we mentioned before, and also another benefit could be helping the aging workforce remain on the job. With an increase in demographics or an aging demographics, I think that would be also an important thing, because when we're talking about tough and difficult jobs done on the final assembly line, sometimes carrying heavy tools and things like that, that require at the same time a good physical shape, and at the same time the right experience, keeping people with that experience, but probably in an aging situation where they're losing that physical shape, thanks to these tools, it will allow to keep that experience, that know-how, and complement the junior component of the workforce with more senior experience and aging population that would keep at least that know-how and that expertise in-house.
Thank you, David. Thank you very much. That's very interesting. So we're is Jim Novak on the line? Can we hear you, Jim? Okay. I don't hear Jim's voice. A little concerned about that. So Jim may be returning to us in a few minutes. I think I'll go ahead and ask Raul, are you with us? And could you please begin presenting? Raul Alarcon from the European Space Agency.
Hi, Christine. Can you hear me well?
Yes, we can hear you. Mm-hmm.
Hi to everyone. Thank you to Christine and the area for providing me the opportunity to say a few words about the state of augmented reality in the European Space Agency.
You're going to need to speak up more. It's faint.
Yes, can you hear me okay?
Yeah, that's better. Thank you.
Good. Well, just a brief introduction about the European Space Agency. The European Space Agency is an international organization with 22 members. That coordinates resources so its members can undertake space programs, otherwise achievable by a single country. ESA is involved in many space activities. ranging from space science, human spaceflight, Earth observation, navigation, robotic exploration, telecommunications operations, and technology development. So we are one of the few space agencies that are involved in so many activities. Next slide, please. Just to give you some key facts about the space business, it's important to bear in mind that from being a low-volume business dominated by public organizations, the space sector is becoming a highly competitive and dynamic environment. Actually, it's demanding a higher effectiveness and efficiency. So we achieve a lower cost and a reduced time to market. However, what happens is that the development of these space products, they continue to require highly complex activities, and these activities are difficult to automate and need qualified workers as well as qualified parts, materials, and processes. As you can imagine, space products are normally not serviceable once they are launched, with the exception of the space telescope, the Hubble Space Telescope, and the International Space Station. Therefore, if a product is developed with low quality levels, then we need to expect that we need to perform overwork and additional testing, which, as you can imagine, this has an impact on the programmatic aspects of the mission, basically the schedule and the cost. Therefore, there is a clear incentive to build reliable products right the first time and avoid any errors. As we usually say, failure is not an option in space. We can recall from the movies easily.
So, Raul, your audio remains very, very weak. I'm a little concerned about that, that it's hard for people to hear you. So we're going to go to the next slide, and if there's anything you can adjust to try to improve your audio, let's go ahead and try that.
Okay, I hope it's better now. I'm speaking very close to the mic. So, basically, in this slide, you can see that several applications of the augmented reality to space. Several studies demonstrate that most errors in industrial manufacturing activities are related to not having or having but not using the right information at the right time. So we believe that augmented reality has a key role to play in this regard for the space industry. Augmented reality systems have already been demonstrated in the space within the International Space Station. It can also be used in a controlled environment like a clean room, in launch facilities, or in ground operations. So basically, augmented reality could work in any environment thanks to the use of wearable displays and other portable technologies like a smartphone or a tablet. We can pass to the next slide. Christine. Basically, here are some examples of projects that we have done in the Space Agency, the European Space Agency. For example, the first one is Project WARE. This was an augmented reality technology demonstrator flown on the ISS in 2009. This experiment explored the use of augmented reality on the ISS procedural operations. Then we have also their CAMDAS, which was an application of augmented reality for medical assistance in the execution of medical procedures as well as medical training. Then we have also PVAITV. This project was aimed to develop an augmented reality prototype to support testing activities at the European Space Agency Space Test Center in the Netherlands. Then in the last picture you can see below, we show you actually two projects. One is MobiPV, which is an activity still running, and its main objective is to explore the use of augmented reality technologies in the field of real-time collaboration. And the EdCard project, which means engineering data in cross-platform AR, which explores an end-to-end application in augmented reality. So basically, it's from engineering data input to augmented reality operations and feedback into the system. Next slide, Christine. We can see the application to space mission assurance. Basically, for those who are not familiar with the term mission assurance, in Europe we usually call it product assurance. We need to consider here also the term of safety. It's important to consider. Um, in our department, we are currently running a study to assess the application of augmented reality in the domain of mission assurance and develop a technology acceptance model and a technology demonstrator. In the frame of this study, we identified a set of business cases, and among these cases, we include the context-sensitive overlay of procedural instructions to perform assembly tasks, as you can see, for example, on the left picture, the training of operators, detecting of configuration errors. This is very common in harnessing, for example, or having a remote expert support, as was explained in the case of David in his slides. It's the similar concept. So if you go to the next slide, Christine, yes,
Yes.
the results of the study highlight that the main drivers for the adoption of the technology would be the reduction of error and increasing compliance with the specifications. So this will be very suitable, for example, in the case of configuration error detection. As you can see there, some other values are also balanced, like reduce cost, of course, and accelerate the introduction of the technology, but reducing error, considering that we were doing a survey to engineers working in the field of mission assurance, is of course of key importance. In the next slide, you can see the barriers. And an interesting outcome of this study was the identification of these perceived barriers to introduce augmented reality in the workshop. As you can see, the main ones are the lack of interoperability with existing systems in the organization. This is a very important concept because certainly the ability to have different systems existing with current existing data operate or interact with the augmented reality system is of paramount importance. And also the customization costs. This is a recurrent issue. Of course, you have to bear in mind that in the space industry, we usually are talking of missions that entail one satellite. There are also constellation missions, but for those where only a one-off is produced, the high cost of customizing an augmented reality application have to be really carefully assessed. So this ends my presentation. I thank you for your attention, and I hope I provided you with a good overview of augmented reality activities in ESA.
Thank you very much, Raul. That was perfect. And thank you, all gentlemen. I'm very sorry that Jim Novak was offline for a few minutes for some technical difficulties. Jim, can we hear you? Do you want to do an audio check with us?
Can you hear me okay?
Yes, thank you very much. Welcome back. I think what we're
Thank
going
you.
to do now is discuss some of the issues that have come up. Very, very interesting to see the variety of drivers and the validation in the study that Raul showed us just a moment ago, the validation about this, uh, having so many reasons for using augmented reality, but in particular, the reduction of errors is a very big one. So I'd like given that as a context in the background, uh, could we um, could we start talking about the barriers? If this is such a highly compelling technology, um, should we? Why isn't it more widespread? And let's go ahead and ask Paul. Could you perhaps tell us, in your opinion, why augmented reality is not more? Are there business barriers at Boeing?
There are actually, yes, as you indicated, there are both business and technical barriers. But so the business one is always, usually comes down to kind of the chicken and the egg scenario where program managers want to see, hard data that they will, improve their operations, improve their program in some way. And getting that data is difficult, when we don't have, significant, or we don't have the ability to generate that data. We don't have enough buy-in to be able to fully implement these things. So it can be, it's a balancing act. So that's actually one of the reasons why we did the study at a university. We needed to get some data that would at least get us started, and that was actually, very good for us. And we've got some of our pilots going on there, but we need more data. We need to be able to point to, this will save you so many dollars, for every task you do, or something, some quantitative data. And then the human aspect, it is also a consideration. I mean, when people are so ingrained, they're so used to working, with say work instructions from one method, paper, for instance. We've been doing that for 100 years. Bringing in new technology, is always, can be a challenge sometimes. Although, generally people are very open to it, but there's a learning curve there. And so when we go to a program and say, we're going to pilot this technology, it can be, an uphill battle to begin with. But I think generally once program managers start to understand what the technology can do, once people get more familiar with it, we usually quickly see a pretty rapid adoption. But there are issues in terms of like integration with legacy systems, which is why we cannot kind of switch this on as an enterprise tool.
Okay.
What we're doing our pilots.
Great. I'd like to ask, Raul, do you see business issues on your side at the European Space Agency? Do you see significant resistance, non-technological, but do you see those barriers in your work?
Well, yes, Christine, indeed. In the European Space Agency, we do not manufacture the satellites themselves. We basically are the end customer. So all the manufacturing and assembly is done by the prime companies, like Airbus, like Thales Aerospace, OHB, etc., and a long supply chain. But certainly there are elements that we need to bear in mind. The organizational culture, I think that Paul has touched on this topic. People being used to a certain way of doing things, this always takes time actually for people to adjust to a new technology. It could be even, we are in Europe, we are subject to labor laws. There could be some employees basically not being willing to be filmed or not willing to participate in this type of introduction of technology. There are other elements more technical, like for example, data integrity and security. Where to store it, how to visualize, when to update it. These are elements that are also important and need to be taken into account.
Okay.
And the last but not least that I can think of is the one I mentioned before, is the integration with existing systems in the organization. It is important for users of any augmented reality system to interface with existing applications and the existing data.
Indeed. I think that's that interoperability and integration component that you just raised is something that Jim has specifically focused on. Jim, did you want to mention yourself in terms of the technological or integration challenges as you see them?
Yes, and this is something that is endemic to the industry. Obviously, it is natural that the manufacturers want to safeguard their intellectual property. So that is very, very much against the interoperable directive. What needs to be done is a sort of Switzerland that would keep the information that must be shared, but protecting the intellectual property. That's absolutely paramount for the industry as a whole to move forward. Obviously, when you're talking about a satellite, the customer, in this case, the European Space Agency, is the owner of that information and can force their suppliers to provide it. That's not the case with an MRO or a maintenance organization that is working with Airbus or with Boeing. They cannot force Boeing or Airbus to give them that information. So there's a tug of war in terms of that 3D design information and how that flows.
Great, thank you for that. David, do you run into some technological or engineering problems that you'd like to raise and share with us?
Well, from a technological point of view, I guess that yeah, one of the issues is whether the technology is mature enough to deliver some of the functionality that we're expecting, and we're talking about yeah, the identification and tracking of objects that may be relevant to provide the contextualized information that augmented reality is meant to do as part of its value adding. It also creates, yeah, because of those technological issues, so far we've seen some reluctance from early adopters, provided or generated or provoked by the dizziness feeling, that feeling of sickness that may create, particularly in confined spaces, where as a tool to visualize, as a tool to inspect, as an inspection tool, was meant to provide significant value, but yeah, some users, early users, are starting to retract until the technology is ready, and those are things that yeah, we would like to see in the technologies, the devices, the platforms that are commercially available and that will be commercially available in order to overcome that reluctance to adopt the technology. Something else that needs to be mentioned that has a technological component but has also a perception component is security. And for us, as an independent providers of these solutions, when working with big clients like Airbus, where security is must, and when we're talking particularly on defense products, is something paramount. Yeah, we're seeing that yeah, the additional risks that this type of technology may bring to the shop floor, and again, they may be real or perceived, are basically stopping us or slowing us down in order to really prove what the value or what the technology can do. In the end, we think that probably there's not a huge difference here between the other technologies that are readily available in terms of or looking at. I'm thinking of tablets. I'm thinking of smartphones. But because in the end, that two-way video and audio streaming capability is what probably concerns particularly the big defense OEMs. But well, yeah, again, whether it's real or perceived, that's something that we need to overcome if we want to see the technology reaching the shop floors, reaching the customers, and again, helping us to deliver the promise that yeah, we think is more than that. It should be a reality in the future.
Okay, thank you. Paul, do you see technological barriers in your work, or are they all taken care of?
Yeah, not quite. So there's a couple that I would mention. I mean, one is aerospace applications typically have higher or tighter accuracy requirements than perhaps some other applications, especially commercial or non-industrial ones. So getting accurate location of parts or tablets and tracking things in 3D space, that is a long-standing problem that many people are trying to solve. It's still, I think, an active research topic. And then secondly, I think one of the biggest technological problems we have is integrating, I think, as I mentioned before, maybe I was getting ahead of myself, integrating these new technology systems like augmented reality with the legacy MES and 3D design systems that we have. The aerospace cycle is pretty long, right? To design a new airplane, for instance, it takes many years. and we get started, and then by the time we get around to making it, the systems are really kind of out of date. Not out of date, but they're legacy systems. They weren't designed recently, and so when we try to plug in these new technology to them, that creates problems. And so we're the whole industry is having a hard time figuring out how to. Now we have the ability to maybe display some really useful 3D content, but we have to get that content from somewhere, and
Okay.
that's a big problem.
Great, great. Yeah, that's this content equation is very, very challenging. Jim, you want to talk a little bit about the costs and please go ahead.
Yes. The question is, how do you get the 3D data into the system so that you can use the fancy augmented reality devices? What I'm proposing and what I would think that might be very useful is before we resolve the 3D repository of data, that we would use augmented reality simply for remote collaboration. And the way this works is that somebody that's at the shop floor or in front of the problem uses an augmented reality headpiece, and somebody that is remote is seeing what that person is doing and can sort of in the air point to or circle the problems where there's no content creation at all. We can resolve some of the human issues and some of the maybe business case and ROI problems. But what we can start to do is start to use augmented reality in a pure, perhaps telepresence manner before we start overlaying 3D models over reality. We can simply use it in a telepresence manner, which I think would give a lot of usefulness to a lot of industrial aerospace, and we also work in oil and gas. Just simply
Thank
a
you,
remote
Jim.
expert helping somebody that's local.
That's very similar what David was describing, and it's good to hear that you feel that that has a lot of potential as well. I'd like to move to our third question, which is around, there are a lot of people who are on this call and who are in other industries, and I wonder what can we apply. It goes in both directions, doesn't it? What has aerospace learned from other industries, and what can other industries? Jim mentioned oil and gas, for example. What can they learn from this, from the experiences that you gentlemen have acquired? David, do you see overlap between your work in aerospace and, for example, in airports or other industries?
Oh, well, actually, we could say that, for instance, our remote support tool started, in our airports business unit. But yeah, that probably is a little bit of a stretch in the extrapolation of the use of the technology, because we didn't even initially conceive augmented reality as part of the solution.
Okay.
Where we think that definitely aerospace could be taking something borrowed, or at least taking some inspirations, is in all the maintenance applications that we may see in other industries, and where, on the one hand, the remote support factor, and on the other hand, the dealing with sometimes complex machinery and complex technology to master could be of application to the aerospace industry. But well, we're fighting this time for the aerospace industry not to be the laggard, because we're not traditionally very risk inclined. But we'll have to see whether the rest of the industry comes along.
Okay, good. Thank you. Jim, have you worked in other industries that in your other company? Do you see overlap, and is there a good opportunity for others to watch what's happening in this industry?
Absolutely. what is known as BIM, or Building Information Modeling, in the construction industry is essentially just defining a building as a collection of objects that relate to each other, and to document all of the interactions, the cost, the logistics of that building during its entire life cycle. That can be applied almost one for one to the aviation industry, to the oil and gas industry, because a refinery is just a collection of parts, just like an airplane is, or a ship. So if we could work on a, let's say, vendor neutral system that defines those parts, and there are some international standards like Spec 2000, IFC, STEP, but unfortunately the software vendors that work with 3D, obviously they have a business reason to maintain their personal models as proprietary, and that's understandable. So it's going to be up to the industry at large to request this kind of interoperability.
Thanks, Jim. That's really good. And you're right, BIM has gone very long ways since it's been required in certain countries. It's been very, very beneficial, I think, to interoperability. So thank you, gentlemen, for your interesting insights in this discussion. I hope that our attendees found this valuable and that you'll join us again in approximately 4 weeks. The next area webinar will be on March 17th, and we'll be hearing from some industry analysts who are studying the adoption of enterprise augmented reality and trying to figure out where it's headed, how fast it's going, maybe who's leading and who's falling behind. It's very challenging to get any accurate assessment of this growth. So that's promises to be an interesting webinar, and I look forward to sharing that with you in about a month. So thank you, gentlemen. Great webinar. Thank you, everyone, and have a nice day.